having two, if you have sp3 hybridized carbon, but it is attached with, it is a tertiary carbon, then no doubt it shall not follow SN2 mechanism, it shall 100%ly following SN1 mechanism. But if it is a secondary carbon, sp2 hybridized but secondary carbon, then it shall follow, it may follow SN1 dominating over SN2 or SN2 dominating over SN1. We cannot 100%ly claim it shall follow 100%ly SN1 or 100%ly SN2. Both shall be competing with each other. You have seen the reason justification done by Sanin in this regard. So different factors we have already come across. So we have changed the substrates. Primary carbon, secondary carbon, tertiary carbon involving entirely different mechanisms. So primary carbon follow van der Waals inversion. Tertiary carbon follows SN1 mechanism causing racemization. Similarly, if it is a secondary carbon, it show a mixed behavior. SN1 may be dominating over SN2 or SN2 dominating over SN1. In that case, the factors you have come across: the polarity of solvent, the selection of nucleophile, the nature of the leaving group, steric factor, all of these counts in secondary carbon case, but they are not that much important for primary and tertiary carbons. Now we are going to change our substrates. Just look at the substrate I have presented in this slide on the left hand side, this one. In this case, we are having R1, R2, R3, R4 subsequents I have get attached here. You can see in this case, I have presented in the center. So this is just look at here, this is a carbon attached with the X. X is the leaving group. And this R1, R2, R3, and R4, these may change. For example, in this case, if R1 and R2, they are alkyl group. If they are alkyl group, it means this is a tertiary carbon, and tertiary carbon follows what mechanism? It always follows SN1 mechanism. So look at this color. This is light pink color. So I have presented this nucleophile approaching this carbon, but it cannot approach until and unless this X leaves. First, this X group leaves, generating a carbocation here. Then nucleophile approach this carbon. And what it shall cause? It shall cause racemization, which we present like this zigzag line. This zigzag line I have very clearly presented before. If any bond is a wedge head like, so it show if it is a bold wedge, it is a bond above the plane. If anything is a pointing behind the plane, so we show this with a dotted wedge. And if we are showing a complete bond, just like a line, normal line, this is showing a covalent bond. If we are showing this dotted line, so this is, if you have seen in transition states, we present that is called half bond. So these are the presentations done. This bond is also presented. What this indicates? This indicates this is at an asymmetric center. And the group where zigzag line is, so this is the mixture of 50% above the plane, 50% behind the plane. This is what we normally call racemization. Whenever there is a racemization going on, we always show this with a zigzag line. So it means racemization is taken place in this reaction, and this is commonly called SN1. But look at the substrate. This is very interesting to notice in this case, that if this carbocation is stable, this is a tertiary carbocation, no doubt SN1 shall dominate. But if let's say R3 and R4, they are hydrogen. So if this X group leaves, this carbon becomes positively charged. So this is a tertiary carbocation because this is attached with 3 carbons, and this is resonance stabilized. The other resonance form shall have a positive charge on this carbon, where this R3 and R4 are hydrogen. It shall be a primary carbon, carbocation. So primary carbocation is very unstable. So that's why if you are comparing with tertiary carbocation, so tertiary is more stable. So this reaction shall follow SN1 mechanism dominating. But if let's say it is not that case, R3 and R4, one of them may be alkyl group, one of them is hydrogen, other is alkyl, then it shall be a secondary carbocation competing with a tertiary carbocation. So then the percentage of SN1 mechanism shall be decreased and SN2 prime shall increase. So what these primes are, it is not SN2 reaction. SN2 could be if it is a stepwise, sorry, it could be SN2 if it is taking place as concerted mechanism in leaving group and nucleophile, they are approaching or leaving the carbon at the same time. In this case, what is happening? The X is leaving first, and then the nucleophile is approaching. So definitely following SN1 mechanism. But if this group leaves and this pi electron transfers there, generating a positive charge, because when this R2 and R3, here there is a steric factor. But if R3 and R4, both of them are hydrogen, there is no steric crowding here. Or if one of them is alkyl group, there is a poor steric hindrance, then the nucleophile can easily approach this carbon. Steric hindrance. So then it is going on, substitution is going on with rearrangement. You see this group is leaving, so rather substitution takes place at this sp3 hybridized system. This is being resonance stabilized by this pi. If this electron group leaves, so this pi electron transfers here and generating a positive charge here, this nucleophile approach this position which is sterically less crowded. So this is not called SN2 mechanism. This is called in fact SN2 prime, although it is also concerted. You see, but this is involving the substitution and rearrangement. Therefore, we cannot call this SN2. SN2 only involve where the leaving group is leaving, the nucleophile approach to same carbon. So that is called SN2, but it is not the taking place. Where the leaving group is leaving, the nucleophile is approaching different carbon. So it is not a SN2 mechanism. We cannot call this Walden inversion. So this is a SN2 prime. SN1 always compete with SN2 prime, and SN2 shall always compete with SN1 prime in fact. All right. So this is a very important to understand SN2 prime, but just our substrate is different. This substrate can be different if we are having an olefinic system attached to a carbon which is having a good leaving group. If next to good leaving group or next to a sp3 hybridized carbon, there is an olefinic system, electron donating system, then it not only undergo substitution, but it also undergo rearrangement. So both of these compete. SN1 compete with SN2 prime or SN2 competes with SN1 prime all the time. I have exemplified it underneath. Let's say the structure which is presented as 1. We are having this carbon. I have presented this X. It may be above the plane or behind the plane, whatsoever is the stereochemistry, doesn't matter. So if we are reacting this with silver ions shall react with this halide ion, generating a silver halide, generating a positive charge here. Now you see this positive charge once generate here, it is a tertiary carbocation. The tertiary carbocation is very stable, so it shall undergo a nucleophile shall approach, kicking out this X, so generating a bond here. So this is most likely it is following SN1 mechanism. This is a no, sorry, this is opposite. This product shall be um, or let's say we shall discuss that later. So SN1 is the mechanism followed in this case. Because substitution is taking place, nucleophile is approaching at the carbon where leaving group is leaving, but following two steps. First, X leaves, tertiary carbon, sterically very crowded, pi orbital forms, carbocation generated, then nucleophile approach above the plane and behind the plane. So this is calling a racemization. But what is the other possibility? If this X group leave and this pi electron transfer, it shall generate a secondary carbocation. Although this is less stable than the tertiary carbocation, but it is competing with this. So this double bond approach here and nucleophile approach this carbon. So a nucleophile once approach is carbon, a new asymmetric center is generated. So it shall be a nucleophile shall be above the plane and behind the plane equally. So in this case, two reactions are competing, two mechanisms are competing with each other. One is SN1, other is SN2 prime. So this is a change in substrate has taken place if you are having a unsaturated carbon system next to a living group. sp3 hybridized carbon you are having where a living group is present. If you have a olefinic carbon system present next to this, so it not only undergo substitution but it also undergo rearrangement. This substitution plus rearrangement is called prime. It may be SN2 prime, it may be SN1 prime. So just look at another example in next page. This is totally opposite. What we are doing, same substrate, but we are defining R1, R2, R3, and R4. They are entirely different. They are entirely opposite. In previous example, you have seen R1 and R2, they were alkyl groups. But here R1 and R2 are hydrogen, or they may be, one of them may be alkyl group. One of them is hydrogen. It means this carbon may be primary or this carbon may be secondary carbon. If it is tertiary, definitely it is going SN1 mechanism. But if it is primary carbon, it shall 100% undergo SN2 mechanism, Walden inversion. But if it is secondary, so we can control low polarity of solvent, good nucleophile if we are having, and good leaving group we are having, then it shall favor SN2 rather SN1. So this is something that this is totally opposite substrate you have seen to previous example. You see here we have control R1 and R2 are alkyl, R3 and R4 are both hydrogen, or one of them is alkyl. This, and in this case this is opposite. R1 and R2 are hydrogen, or one of them is alkyl, R3 and R4 they are alkyl groups. This is story is totally changed. If you have a substrate like this, then the nucleophile, if approaching this carbon at the same time this X group is leaving, it shall follow SN2 mechanism. But if it is going like X is group is leaving, I have presented this with a purple mechanism. This X group is leaving first, it is leaving, and these pi electrons are also transferred at the same time, and nucleophile approach this carbon rather this carbon. So what is happening? Not only substitution, but rearrangement is also taking place. So because tertiary cation is forming over primary or secondary carbocation, so this is more stable. So SN1 prime shall dominate in this case rather this one. So I have presented here wrong. In fact, the previous reaction, if you have seen, this is the major product and this is the minor product, because this involve a tertiary carbocation. In fact, it has been interchanged. Here, SN1 should be major and this should be minor. But in this case, what we are having, this should be major and that should be minor. So this is a little bit opposite. So in fact, get this change yourself. In fact, this is minor because SN2 is taking place here. If we are having a secondary carbon, it is fast. But SN1 prime is generating a tertiary carbocation. As a result, this nucleophile shall approach, which is more. So this shall be major product and this shall be a minor product. So in this case, you are having in fact a simple substrate, totally opposite to previous, where this carbon is primary, generating, undergoing nucleophile following Walden inversion, SN2, 100%. But on the other side, if we are having an alkyl group present here, it shall also undergo substitution, but mostly SN2 it shall follow. But in this case, it may be this carbon pi electronic density can be transferred there, and this carbon becoming electron deficient can react with the nucleophile. So this is generating an entirely different type of the product. So one of them is major, other is minor. SN1 in previous example you have seen SN1 was competed with SN2 prime, but this here it is opposite. SN2 is competing with SN1 prime. This is totally opposite to the previous example. This is only possible when we are having this type of substrate. Substitution taking place at this carbon. If there is no conjugated system, it shall either substitute it by SN2 or SN1 mechanism. But if there is a pi electronic density available, double bond is present, then it may undergo substitution, including rearrangement. All right. So these substrate is a very special type of the substrate. And similarly, look at SNI mechanism. In next slide, this is the SNI prime mechanism. So what is an SN mechanism? If you SNI mechanism you have come across, if we have a normal substrate, let's say there is no double bond present here, so it reacts, any alcohol shall react with thionyl chloride SOCl2, generate this bond. If you remember, sulfur oxygen double bond to chlorine, this is a very simple addition to sulfur oxygen double bond. This alcohol is acting as a nucleophile shall add over there. This mechanism we have already come across in SNI. So oxygen shall bond with sulfur and having one chlorine and one oxygen. So this is the system you are already having. What happened here? This chlorine migrates or transfers from sulfur to this carbon, and this electron pair transfer. This is what we call SNI. Substitution, nucleophilic, intramolecular, right? And because leaving group where leaves from same direction nucleophile is approaching, so configuration is retained. This is the unique feature of SNI mechanism. But when we are having a substrate like this, we are having a sp3 hybridized carbon next to a olefinic bond. In that case, not only the this SNI is undergoing, but it may be competing with SNI prime. Means if it is leaving, this electron pair is transferring there. This is pi electron may be transferring here, and this chloride ion may be transferring at this position. So this is a very unique, interesting example. But how it proceeds? Let's say I have presented in this structure number 2. I have restructured this one. This is having a R absolute configuration. Yes, first priority shall be oxygen. Second is one is methyl carbon. This is a olefinic carbon. This carbon is attached with one hydrogen. This is attached with three hydrogen. This is more superior than this one. So this oxygen first, this group second, this third. This is having a clockwise rotation. So this is R group. So it is a R absolute configuration in fact. So this is also R in retention of configuration take place throughout SNI. This is also R group. All right. So let's say if it is not undergoing this mechanism, this R is not transferring here. So group is leaving and new nucleophile is approaching from same side within the molecule. So to cause a retention in configuration that you have come across SNI, but it may be SNI prime. Now what is SNI prime? I have presented here. Look at here. I have remodeled this structure, chlorine, sulfur, oxygen bond. I have restructured. Likewise, this double bond, methyl, carbon double bond. I have presented likewise. This is next is asymmetric center. I have presented that asymmetric center. It is attached with oxygen, sulfur, chlorine that I have presented likewise. What happened? This Cl leaves with electron pair transfer to this carbon, and this carbon donates this electron pair towards this, and this bond transferred here to generate a sulfur dioxide, and chloride is transferred. So what it shall result? It shall result in the formation of the centrifugal structure number 4. Now you see, this is not only a substitution, but a rearrangement has been taken place. So this shall be called as SNI prime mechanism. So in fact, I have presented the structure number 2 likewise this. Why this is? Because this you see chlorine, sulfur, oxygen, carbon, carbon, carbon. So these are 6 position, 1, 2, 3, 4, 5, 6. So it is acquiring a 6 atom system which undergo a chair conformation. I have presented that transition state, how this reaction takes place. Because this is a concerted. This bond is breaking and making a new bond here. You see from asymmetric center, this bond is cleaving. And a new bond is forming, but not at asymmetric center, a double bond is formed. So it here rearrangement and substitution both are taking place. Here only substitution is taken place. So for your clarity, I have presented in this structure SNI mechanism is followed. But when it is going likewise, this a chair conformation, you see these two carbons having methyl groups. One methyl is pointing axially upward, other is pointing equatorially downward, right? So it is bonded with, this is a symmetric center where we are having a methyl here and a hydrogen is pointing about the plane. We have a oxygen attached here, S double bond O attached here, and then a single bond is being presented here with chlorine. What is being presented here, bonds in dotted line, they are half bonds because this is a transition state. Alternatively, you are getting red, alternatively, you are getting green. The green one are the bonds which are new bonds forming, and red bonds are those which are broken bonds. So mean these reds are such bonds which are breaking, and 3 bonds are breaking. One pi bond is breaking, one this sigma bond and this sigma bond is also. 2 sigma bonds are breaking and 1 pi bond is breaking, and 1 sigma bond and 2 pi bonds are forming. This green color is showing bonds formed. So 2 pi bonds and 1 new sigma bond has been formed in this reaction, resulting in the formation of this product. So this is called SNI prime mechanism. So here SNI is competing with SNI prime. If you are having an olefinic system attached next to a symmetric center, so what is the unique feature among this? In this case, when substitution is taking place to a substrate, where substitution is taking place, if it is attached to an olefinic system, so it shall not follow SN1, SN2 or SNI. It follows entirely different mechanism. If it is having a primary carbon where leaving group is present, and so it can follow SN2 competing with SN1 prime. If it is SN2, it is following SN1, it shall compete with SN2 prime mechanism in fact. So this is what we have come across. But if SN, you are having very similar substrate, an olefinic system next to a symmetric center where SNI mechanism is being involved, it may undergo, you see here 4 atoms are involved, chlorine, sulfur, oxygen and this carbon. So 4 member doesn't undergo their cyclic ring formation, but this is a transition state, which is a 6-member transition state, a chair conformation. If you remember, chair conformation is a very stable entity. So here, this structure number 2 is converting into 4, involving a substitution as well as rearrange. This double bond from here is transferred to this position. At that position, this OH is being cleaved and Cl is bonded at this position rather, where substitution should be taken place. So this is involving not only substitution but also rearrangement. So this is called SNI prime mechanism. So we are short of time.